Let's do some problems on this practice test right here. All right? Okay. What is the average acceleration of the object from 0 to 6 seconds? Okay, acceleration equals change in velocity over time. In 6 seconds, we've got to assume this is 2, 4, 6. You have to pretend the line looks like this. It goes from 0 to 6 meters per second in 6 seconds. So the change in velocity is 6 meters per second in 6 seconds. So obviously it's 1 meter per second every second. Number 2, how far has the object gone in 14 seconds? Boom. The area under the curve on a velocity over time graph is equal to the distance traveled. So I can make, I don't know, we'll make a triangle there. We'll make a triangle here. We'll make this square here. And then we'll make this guy a big square. And we'll add up all the area under there. So let's see, this is 8 by 2. So 8 is the area of that triangle. This one is, this goes from, let's see, 2 to 14. So this is 12, no, excuse me. I gotta do this right here. This square right here. So this is from 2 to 10. So this is 8 by 8. So 64 is the area of that square. This tiny little guy right here is 2 wide by 4 high. So he's got an area of 4 for that little triangle. And then this square right here is up 4 over 4, 16. So 16 plus 4 is 20, plus 64 is 84, plus 8 is 92. 92 meters, okay? 2 cars are in a race. One travels at 12 meters per second and the other at only 9 meters per second, but the slower one has a 4-meter head start, all right? So we're gonna draw that, all right? And it says it wants us to draw this. Draw a qualitative graph of the race. Okay. So the slower one, right? This is our distance up here. This is our time right here. So the slower one has a 1, 2, 3, 4-meter head start. Remember, it's qualitative, so we don't have to actually write any numbers on here. And then the other one's traveling faster. There you go. That's qualitative. This is the slower one. It has a head start, and this is the faster one. It started at the start line. After the fast car starts, how many seconds before it catches the slower car? All right, so now we got to do some math. The fast one has a speed of 9 meters per second, and it will take so many seconds. Now remember, we're using this formula. XF equals VT plus XI. And remember, this is just a line slope formula, okay? Now, since there's no XI, the whole formula for the first car is just 9T. Now, the next car, it has a head start. It's going 9 meters per second for so many seconds, and it has a 4-meter head start. So I'm sorry, the first car, I wrote this down. The first car had a velocity of 12 meters per second. I bet you were confused by that, weren't you? So 12t is equal to 9t plus 4. We're going to do some math here. 9t over here, it leaves us 3t is equal to 4. And to solve for t, 1.33 seconds. That's how long it would take. How long would it take? 1.33 seconds. How far down the track would this collision occur? All right, well, we can just use this formula. 12 meters per second for 1.33 seconds will give us 16 meters. That's how far down the track. If I'm going fast, people, this is all a review. There are many assignments with me working this, many examples for you to look up and just flip back through your Google Classroom. It's all there. A car accelerates from 0 to 16 in 8 seconds. Graph this below, adding numbers to the velocity graph on the right. A qualitative line is fine for the distance graph on the left. Okay. Here we go. All right. First of all, the distance graph will be like this. Accelerating gives you a curve, gives you an even curve on a distance over time graph. Okay. Now this one is velocity. All right. So it says from 0 to 16 in 8 seconds. So 0, and then our top speed will be, we'll call this 4, 8, 12, 16. So we go from there and 1, 2, 3, 4, 5, 6. And we'll call this 2, 4, 6, 8. This is seconds. This is meters per second. So we go from 0 to 16 in 8 seconds. That's exactly what that would look like. Does that make sense to you? From 0 to 16 in 8 seconds. Okay. All right. Hey, what acceleration would that be? That would be acceleration is equal to change in velocity over change in time. 2 meters per second is the acceleration of that car. Let's keep rolling. Okay. A skater rolls down a ramp, rolls at 4 meters per second for 15 seconds. Okay? For 15 seconds. Here he is skating. Looks like he's having fun. He comes to a slight decline and accelerates at 0.11 meters per second for 17 seconds. So he starts going downhill, and his acceleration here is equal to 0.11 meters per second, and he does that for 17 seconds. Okay. Then he hits a wall and stops. What was his maximum velocity? Okay. Well, he was going 4 meters per second at first, and then he increased his speed by 0.11 meters per second for 17 seconds. So he increased his speed by 0.11 17 times. Does that make sense? So 0.11 times 17, he increased his speed by 1.87 meters per second, and he was already going 4 meters per second. So his final velocity is 5.87 meters per second. That should make sense. How far did he skate total? That leads us up to this formula. XF equals XI plus VIT plus 2A delta X. We had a whole assignment on this. Multiple assignments, sir. This is in several different videos, and we've done several problems. The initial distance right here is how far he skated on the flat. So he skated at 4 meters per second for 15 seconds. So 60 meters is his original distance. Now, this part of the problem right here is about the slope. So we use the time on the slope, so 17 seconds. His initial velocity going into the slope was 4 meters per second, 17 seconds on the slope. 2A, his acceleration is 0.11, delta X. 2A, oh Lord. It's not 2A delta X, people. Please. You know what goes here. XI plus VIT plus 1/2 AT squared. I apologize. My brain was not working. I'm doing these formulas off the top of my head. You got to stick with me. Plus 1/2 0.11 T squared. 17 seconds on the ramp. 17 squared. And then we can add up this whole thing to find the total distance that he went. All right. Let's see. We got 60 meters right here plus 4 times 17. 68 meters plus 1/2 0.11 times 17 squared. So it's a 17 squared times 0.11 times 0.5 equals, that's going to be 15.9. We'll add up all of these, plus 68 plus 60. 143.9 meters. That's how far he went. Sorry about that formula being wrong at the beginning. That was pretty bad. Number 10, a ball is bounced to a height of 25 meters. How long was it in the air? Total, up and down. Okay, shortcut. Here's our famous shortcut problem here, right? The shortcut problem is xf equals 1/2 at squared. So it fell 25 meters. 1/2, what is the acceleration of gravity? 9.8 t squared. We got to fall for this t. Now, would this t be the up and down, or would it just be the down? That's right, it would just be the down. So let's solve for that. 1/2, 4.9. 4.9 t squared equals 25. 25 divided by 4.9. Square root will give us t. All right, 25 divided by 4.9 equals square root. It fell for 2.26 seconds, but it says, how long was it in the air? So we're going to have to multiply our answer times 2, because we just calculated the fall time, 4.5 seconds. What was the speed of the ball at its maximum height? 0, haha. Come on now. It stopped at the top. What was the max velocity of the ball as it fell? All right. Well, we can just really simply say acceleration is equal to change in velocity over time. The acceleration on Earth of gravity is 9.8 meters per second. The change in velocity is what we're looking for, and it fell for 2.26 seconds. So 9.8 times 2.26 gives us 22 meters per second maximum velocity. On the graph at the very top of the page, what is the car doing for the first 2 seconds? And that's this graph it's talking about. It's accelerating because its speed is increasing. It says, please give a one-word answer, accelerating. James Stewart, the fastest man on the planet, was riding his dirt bike at 23 meters per second when a worker crossed the track in front of him. So we have an initial velocity of 23 meters per second. This is a true story, by the way. It took him 0.7 seconds to react. So we have 0.7 seconds. What distance did he cover in that time? Distance. So we have velocity, distance, and time. Oh, we can just use velocity is equal to distance divided by time. This problem was so easy it probably threw you off. If you're going 23 meters per second and it takes you 0.7 seconds to react, he went 16.1 meters during that time. Okay. Now, you have not seen a problem like this one as often, but very simply, we're going to just look up what we've got. A car pulls out to pass a slowpoke who's going 22 meters per second. So that's our initial velocity. They were stuck behind them for a long time. Ugh. It takes the car 3.3 seconds to speed up, so we have a time, to 27 meters per second, so we have a VF. What was the acceleration during that time? Okay, so we have a change in velocity and time, and we're looking for acceleration. So that one was crazy easy. Acceleration is equal to change in velocity over time. It changed from 22 to 27, so 5 meters per second in 3.3 seconds. So the acceleration was 5 divided by 3.3, 1.5 meters per second. Okay? Number 16 is harder. How far did the car travel during that time? Now that's the new formula that you haven't seen as much. But let's look what we have. We've got VF, VI, T, A, and we're looking for X. So what formula has VF, VI, T, A, and X? And that's this formula right here. VF squared equals VI squared plus 2A delta X. This is the fourth formula down on your sheet. You need to always be looking at your sheet. You can always use your sheet. That's not cheating. Using the formulas is not cheating. This is physics. You're welcome at the formulas. Here we go. The final velocity was 27 meters per second. The initial velocity was 22 meters per second. 2. The acceleration was 1.5 meters per second. 2 times 1.5 meters per second. How far did they go? All right, how far did they travel during that time? So we're going to say 27 squared minus 22 squared divided by 3 equals X. I just did some algebra 1 there. You can replay that if you don't know what I'm talking about. Let's try it. 27 squared minus 22 squared equals divided by 3 equals about 81.7 meters was traveled during that time. Hope you enjoyed this video, or at least you can use it.